Dear students, today we will learn about atomic force microscope or AFM. In the last class, we have seen the working principle of STM. In that, we created the image based on the tunneling current. In AFM, the atomic and molecular forces are monitored, and it is used for the surface characterization at atomic scale. In AFM also, there is a probe. Actually, it is a cantilever beam with a sharp tip at the free end of the beam. And the tip will be moved very slowly through the surface of the sample. As it moves through the sample, since the surface is rough, it will move up and down. That means the cantilever will oscillate based on the structure of sample. And in order to record this fluctuation, we can use a laser and a detector, photodetector. The laser beam will focus to the head of the beam, to the cantilever beam, and the reflected rays are captured by this photodiode or photodetector. As the beam moves up and down, the angle of reflection is going to change. So the oscillations of the beam are recorded and produces the visible profile or the image of the sample surface. Okay. So the AFM can produce high quality 3D image with very fine details of the sample surface. If the tip of the probe is very sharp, then the resolution of the image, it will be much better. Then when you introduce the tip very close to the sample, there will be different attractive and repulsive forces. Now let us check this in detail, that is in atomic level. Consider two atoms, they are placed close to each other. Then the positively charged proton, it will attract the negatively charged electrons in the other atom. So there is attraction. And if the atoms are very close, then the electrons in the atoms will repel each other. And here the repulsive force will become superior, and it will overcome the attractive force due to the protons. Okay. So in AFM, we use a nano-sized sharp tip, and that can be attracted or repelled by the sample atoms. Now we can see the working modes. Mainly there are three working modes. First one is contact mode, second one is non-contact mode, and the third one is tapping mode. In contact mode, the distance between the probe and the sample, it is very short. So there will be repulsive force. As a result, the cantilever is repelled. And here the resolution obtained by this mode is very high. That is advantage. And the process is very simple. But because of the short distance, the probe may collide with the sample. So both the sample and the tip, they may get damaged, and it is one of the major disadvantages. Then in non-contact mode, the distance between probe and the sample, it is kept large. So the cantilever is attracted. Here the resolution is very low, but the sample and the probe is not damaged. Then in tapping mode, the distance between the probe and the sample, it is kept intermediate. That means there will be attraction and repulsion. So the cantilever will oscillate. And here the resolution obtained is better than the non-contact mode. Now we can see the advantages and disadvantages of AFM. It will have better resolution than STM. And the 3D image of the sample can be easily obtained. In STM, the scanning is limited only for the conductive films, conductive samples. But in AFM, it can be used on both conducting and non-conducting samples. It is a big advantage. Then the disadvantage is the scanning speed is very low. Then if the tip comes in contact with the sample, then that may damage the sample as well as the probe. And this will reduce the resolution of the image. And in the next class, we can learn about X-ray diffraction analysis. Okay, thank you.